Welcome everybody. My name is Ishak. I am a SUSE field engineer, formerly of Rancher Labs. And today's presentation is going to be a discussion, a grab bag of Istio best practices that I've seen in my tenure at both organizations. The way that this is going to be structured is broken down into four main categories. There's going to be an Istio configuration tip section that's going to have some components that you can configure with standard off-the-shelf Istio. There's going to be Istio supplementary tooling. This is going to be a list of ways that you can improve Istio with a couple open source projects that you can find and add to your Istio service mesh deployments. Then the next category is going to be Istio upgrades, in which I talk about just the basic Istio upgrade functionality, what's available as of the 1.7, 1.8, et cetera, releases, and then Istio futures, so that if you are going to start investing into Istio, make sure that you're making the right commitments to the right parts of it, and not focusing on any of the tools that will soon be deprecated or require a lot of rework in the immediate future. That being said, I always have to preface any discussion that regards Istio with a slide like this. The main idea is that Istio is still a very complicated and sophisticated product. Don't just blindly take anything that I show here today and run it in your environment. There's going to be a couple things that you need to validate before you find out whether or not the situation applies to you. In the first column, you'll see that you definitely have to make sure that you're running the correct versions of Kubernetes and or Istio. This is less important with Istio as of late because they haven't made as dramatic changes as they did with the 1.4 to 1.5 to 1.6 transitions, but it's still relevant. There are going to be some features that I mentioned here today that are going to have changed from version to version. Check the Kubernetes version. This one also is not going to be too paramount. I would definitely recommend checking the Istio version prior to checking the Kubernetes version, but there are going to be some compatibility differences between the versions. Next column is check if the example applies to your specific deployment model. If you're familiar with Istio, you should be familiar with the fact that there are multiple ways to install and manage an Istio service mesh. Helm operator and Istio CTL. If you're installing things with the alpha Helm charts, then chances are that some of the operator configs that I might be showing you today wouldn't be applicable. And there's a case that Istio CTL, some of the functionality that I may show won't be available to your standard Istio CTL without your standard Istio CTL installation. Third column is check if the mesh configuration is similar enough. Assuming that you have the right Kubernetes version, you have the right Istio version, you've installed Istio in a similar fashion, you want to make sure that it's configured in the same solution space, I guess I should say. Whether or not you're using the multi-cluster functionality would make a big impact. Whether or not your organization is designed to make use of the things that I show you, and then whether or not the specific components are being utilized in the same way at your organization. And the last category is that I am by no means the sole expertise on Istio. If you find something that conflicts with what I said, generally speaking, I would probably look at both of them and see which one has the most logic applied to it. I'm just going to show examples. I'm not necessarily going to show you production qualified installations or solutions. And then the last statement there is these examples are field tested, but general advice does not supersede the advice of expertise within an environment. So if you have an engineer that's been working on your Istio deployment locally and they're doing things in a certain way, chances are that they're doing that in a certain way because the environment either dictates it or it makes the most sense in your circumstances. If you're accepting of all of that, then hopefully you get some value out of maybe all of the examples that I show here today. And if not, at least you'll be aware of what's going on in the ecosystem at large and be able to make decisions for when your environment or your circumstances may change. So starting with Istio configuration tips. The first one, and this is going to be remember this is going to be a configuration within an Istio service mesh using just the Istio primitives. You'll see that this is the TAP Envoy filter. Envoy filters are a custom resource that Istio introduced not too long ago. And the TAP filter in specific is going to give you a lot of observability benefits within a debug period, or if you need to really lock down certain requests that are passing through your environment. The TAP Envoy filter can be configured in two different ways. Today I'm going to be showing you the HTTP TAP filter, just because that's the easiest to maintain with the Envoy resource that I have. It will require additional configuration outside of the Envoy filter resource itself. This may change depending on how your Istio service mesh is deployed. But you'll see in the example that I'm using, the book info project that we all know and love, it's going to require an additional sidecar volume mount of an ephemeral temp directory. And then the last thing that I'll mention when I'm showing the actual resources, the HTTP TAP filter accepts two configuration modes. One of them is going to be a more dynamic configuration, and then one of them is going to be a static configuration. We're just going to pass things in statically through an Envoy filter. So if I can switch over to Chrome, I'll show you the environment that I have that's running that. Cool. So this is a Rancher environment. This is the Explorer UI. If you're not familiar with it, that's okay. I'll be pretty verbose in where components are and what's actually happening. But the main thing I want to show you is that I am running a cluster that's pre-installed with some of the TAP components, and I'll show you what those components are. You'll see that I'm running Kubernetes version 120.6. I'm running with RKE because it's generated by Rancher. Then if I click Cluster Explorer, you can see that I've installed monitoring, which is the standard Prometheus stack, and Istio. The reason I've installed monitoring and why that's relevant is because through the Rancher console, monitoring is going to be something of a dependency so that you can get access to Prometheus for the observability in your mesh. But if we click on Istio, the first thing let's take a step back. Let's look at the actual Istio version that I've deployed so that you can follow along and choose the specific version that matches. This is version 1.8.3. And this is, like I mentioned, installed through the Rancher installation method. If we go into the Istio window, you can see the Istio custom resources on the left, some of the configuration options. The main thing that I want to point out is that there is an additional Envoy filter. The rest of the Envoy filters come standard, but the one that I want to focus on today is this TAP filter down here. If we click on TAP, we can see that it follows the same Envoy filter syntax, and that there's a config patch. In that config patch, there's basically selection criteria to find out what parts of the Envoy configuration you're going to target, and then what's actually going to happen with that configuration. And so just in a brief explanation of what's going on here, there's for every traffic, all of the traffic that's coming inbound to your sidecar, that's going into the filter chain for the HTTP connection manager, we are going to manage the router filter. And what we're going to do is we're going to insert the Envoy filter that we have specified that follows, that will, on matching headers, send the log output of the request as a JSON body to a pre-specified location. That location here being /temp/temp. The header that we want to focus on is going to be trigger sample capture, and the value is going to be true. And it's important here that I mentioned that it has to be an exact match. So just having the header present isn't going to be enough. It's going to be trigger sample capture equals true. So now if we look at the cluster itself, let's find out what that actually looks like. The component that I want to show is in the default namespace. We'll see that this is the standard book info project. But the one thing I do want to show is that if we edit the YAML here, we can see that I've added an additional annotation. That annotation, the annotation that I've added is, actually, let's see whether or not I have added that annotation before I suggest that I've already done it. We're going to look at the book info project to make sure it's up and make sure that everything's working as expected. To do that, I need to first find the node that I'm running on. This is all going to be exposed through a node port. And then we need to find the port that this service is being exposed on, product page. Actually, I want the service in the Istio system because I'm looking for the ingress gateway. Ingress gateway 31380. So if I put that 31380 product page, you can see that that service is up and running as you'd expect. Going back into the Rancher window, let's go into the product page deployment. And we will exec into one of the containers just to see whether or not things are configured the way I expect them to be. We'll bring that up so it's a little bit more visible, make it a little bit bigger so it's not too difficult to read, maybe one step. And if we change to, let's go into temp, we'll see that there is a tap JSON configuration, and what that looks like is tap. We will see a JSON breakdown of the request and the response. So here we can see the request with the headers. The header that I sent earlier was trigger sample capture. The value was true, along with all of the other headers, some of the headers that have been added by the gateway. You'll see the trace ID, the span ID, the parent span ID. Sometimes those are hard to pin down, and it's nice to have access to this. And also you can see the response headers. So it was a 200 request, everything was successful, pure metadata, and then you can see the body itself if you needed to. And so just to prove that out, let's switch over to my terminal. Once I copy over the request information, and we will generate a new one. We will add the header trigger sample capture true product page. We'll see that that was successful. And then if we switch back over to Chrome, I will be able to show that that deployment or that request itself was visible. Execute shell, change directory temp. We'll see a second, tap JSON, and then we'll see that the timestamp matches the date of this recording. So if you've worked with Istio for a little while, you'll see that that's a step above the general access logs that Istio provides. This will give you the ability to say, I have a request that's failing 0.5% of the time, and it's failing when it's under these situations. So you can send a whole bunch of pointed and more surgical requests to that endpoint. And depending on the service that you're exposing this directory to, you can find out how it may be reacting in that given scenario. If I switch back over to my PowerPoint, we can keep going. So I found that very useful in my experience. I hope that you do too. If you're going to use it in a production environment, I would probably pin it down more to sidecar, to not just the sidecar inbound, but focus on specific traffic, maybe a specific cluster, something like that. But I'll leave that to your discretion. Another common or more common solution that I've run into in the wild as of late is using Istio's multi-cluster mesh capability and its extensibility to kind of blur the lines between what is in your mesh and what is not in your mesh. The option that I have on top is that if you want to do full integration testing, but you don't want to redeploy your integration environment again and use all those resources, you can use the multi-cluster mesh configuration to point to services that are in your dev, maybe a different staging environment and then have them react with the rest of the mesh or the rest of the microservices in your ecosystem that are running at a higher environment, that have been stable and are as close to production as possible in the way that they're configured. The next option, that's I guess one step below that, would be to add a personal VM to your mesh. Maybe you do all of your development on a VM running either in the cloud or in a data center or something like that. You're just running on a thin client on your local machine. If you add that VM to a virtual machine, or add that VM to your service mesh, you'll be able to deploy a service on that VM, expose it in the way that you normally expose a service, and then integrate that directly into the mesh. That's a method that I haven't seen too much in the wild, but I imagine it'll start to grow because with the release of Istio 1.9, a lot of the VM functionality has been streamlined, and integrating VMs into an Istio service mesh has become much more standard. And the last option, which is definitely a more involved option, but not involving the multi-cluster mesh approach, is going to be connecting your laptop to a service mesh. And this is an example I pulled from an IstioCon presentation, and I will go over a couple of their links so that I can show you just how this would be structured. If I switch back over to Chrome, I can switch to the next tab. This tab, if you look, is Omeo Labs Dev Route. The Dev Route is going to be a setup that, as you can see here, will use an EnvoyFilter to go from a service to an external service that's running on your laptop and then back into the mesh. This is similar to the multi-cluster mesh option that I talked about before, but without actually adding your laptop to the service mesh. And the way that this is done, if we look at the blog article where they discuss it, we will see that just beyond that simple discussion, there's actually a router that's going to intercept the requests and extend them to your laptop. So similar to the way that I did a tap request and that I triggered it with a header, you'll see that there is an xDevRoute header down here. This xDevRoute header will trigger it so that the Envoy service will, instead of going to service B, will go to B prime in this case, and it'll go through the dev router. The dev router will then handle the traffic, handle the communication between the mesh and your laptop. This obviously will come with greater security implications because you'll just be adding a laptop, which you may or may not have full control over. But I would definitely recommend looking into this, just if nothing else, to get ideas onto how you can leverage pre-existing Istio configuration to enhance your development environment. If we go back to PowerPoint, there we go. See that kind of rounds out the ways that you can start or meshing together your different meshes and the way that you interact with a service mesh. The next section is Istio supplementary tooling. This section has a lot to it, and so I'll probably spend a fair bit of time here. But the main idea is that Istio, like I said at the beginning of this presentation, is still very complex and sophisticated, and there are other tools that help the development of standard Kubernetes resources that can be applied to Istio as an application and help you become more effective as Istio admins in your organization. The first one, starting from top to bottom with the ways that I would probably recommend looking at them, is Helm starter packs. Salesforce has done a good job they also had an IstioCon presentation that I liked that showed how they use Helm starter packs to help you deploy Istio as a developer without having to be fully understanding of what the configuration options are. The next situation that I want to talk about is using dynamic admission control to enhance your Kubernetes components into more of a service mesh perspective. For example, If you're familiar with Kyverno, Kyverno has the ability to, with a webhook, to generate resources based on the modification of another resource. So an example of what I mean by this would be if you wanted to, upon creation of a deployment and a service, create a static virtual service that goes along with it, not necessarily tie that into a gateway or anything, but just make sure that there's a virtual service object that's created that could be leveraged. That would be a way to do it. I have an asterisk there to use caution, because when you're implementing a system that's going to require the use of side effects from the dynamic and mission control, that's going to be mostly outside of what the primary use case for dynamic and mission control would be. And so there are going to be unintended consequences, and just make sure that you've tested this out thoroughly in your environments if you're going to go down that path. And then the last option I want to talk about is implementing your own proprietary controller for managing the various aspects or various interfaces of the Istio resources. I have two examples down here, and we'll go over them in a second once I'm done explaining them. There's the first option, which is a virtual services route controller, which is going to, with a label, it's going to join services as you create them to a virtual service so that can be routed. So if you have multiple teams deploying different versions of something that could be construed as the same service, this would be a good use case for that. And then the second one is going to be a rate limit operator. So you're probably familiar with what a rate limit is. A rate limit in the Istio sense is going to give you a very pointed situation in which you can determine how many requests you want to be done, you want to actually succeed on a given endpoint. And the rate limit operator is going to give you another CRD that kind of extracts that from the built-in Kubernetes or the built-in Istio components and gives you a more universal approach to how you would configure that. And this is a good example of changing the dimensionality of Istio into something that fits your organization slightly better. But now if we switch over to Chrome, I will switch over to first the Helm starter packs. Like I said, to start out with Salesforce Helm Starter Istio, there's a lot of good README information here, as well as how you would actually use them. The main idea here is that you're using this repo as a template for the creation of other Helm charts. So we'll see that they're broken down into basically three or four categories. There's going to be a mesh service, which is probably going to be your workhorse. There's going to be an ingress service that would be in the book info project case. That would probably be the product page section. And then the mesh egress, if using the book info project as an example again, I believe it's the rating service that has the potential to go to an external data store. That could potentially use an egress. But if we break down the mesh service, we'll see that this is just a set of templates. In those templates, you'll see standard Kubernetes resources as well as standard Istio resources. Here you can see there's the destination role, there's a virtual service. If we go back into the ingress service, there will be additionally some other components. If we look at the gateways, we should see a gateway resource deployed in here somewhere. And then if we look at the mesh egress, we'll see that there are some other configuration options. Without going too into detail of that, they do have samples if you wanted to run the Istio book info. If that's something you're familiar with, I would recommend taking that for a spin. The next option that I mentioned was using, I won't have a demo or a link to point at with Kyverno, but they do have generating resources on their documentation. And so skipping over that category and going over to proprietary controls of the service mesh components. The first one I mentioned was a virtual services route controller. And the example here shows you that you're applying a label to a service as how it would show what virtual service it applies to, and then that's automatically configuring the virtual services object. I will say this project itself isn't actually maintained, so I don't just run it in the wild. Just use it as an example of maybe some way that you could design Istio interactability within your environment. The later option, the second example that I showed you, which does have more recent maintenance as it was demoed at IstioCon, is the rate limit operator. The rate limit operator, if we look down here, is going to have its own custom resource. This custom resource, as you might expect, is going to be called a rate limit. And this rate limit is going to apply to a specific cluster. That's a cluster in the Envoy sense, a request per unit, and a rate. And then it's going to apply it to a target reference. So here we can see in common English that it would apply to the name VS in the namespace target to a rate limit for any request that has a header with remote address set to custom user IP. You could set that to 100 requests per second, and then it will be to anything that's going to the destination cluster server namespace target service.cluster.local. There's an example here, but the main thing that I want to impart upon you guys is that you could set up rate limits in other ways using Istio components, and this is a good way to isolate the maintenance of that. So that if rate limiting is something that you find yourself doing on a regular occurrence, this would definitely ease the burden of all of the additional components that you can configure and expose a single endpoint. This additionally will give you the ability to modify to scope the cluster role-based access control specifically to rate limit concerns, which is nice. So now if I go back to PowerPoint, we can talk about the next section. Sorry about the aggressive cut, but my camera died and I found a logical space to splice the two sections together. To continue on, the next section is Envoy and OPA. With this example, you'll be able to use OPA in a sidecar alongside Istio as a sidecar and deploy authorization policies using Rego. The components that are required to deploy this are going to be the mutating admission webhook that is going to inject the sidecar, kind of like Istio proxy does, an EnvoyFilter that's going to tell Istio, the Istio proxy, to communicate with OPA for the authorization requests. And then it's going to have two or more config maps, one of which contains the Rego policy, and then one of which contains the OPA configuration so that the sidecar knows what to do with the incoming requests. So if I cut over to Chrome, I'll be able to show you, well, actually, let me cut over to Chrome first and then my terminal. Here in the OPA policy agent OPA Envoy plugin Git repository, we'll see that they have examples for Istio and Glue Edge. If we dig into the examples directory, we'll see a little bit more user-friendly documentation in the Istio section. We'll see that, like I had mentioned, there are two sidecars, the Istio proxy and OPA, and the installation is going to use this manifest, but the main components that I want to talk about are how to prove that it's actually doing what it says that it's doing. And so down here at steps 5 and 6, we'll see that if we make a request against the book info product page URI, we'll see that Alice currently has access. But if we make a request against the same gateway but a different API, we'll see that she does not have access. Similarly, we should see that Bob has access to everything. And this will be done through sidecar requests. So just to show you the environment that I have, if we look at the Envoy environment, I'll make this slightly smaller so that it makes sense. We'll see that in the default namespace, we have all of these projects, or we have all of these deployments. And for instance, if we look at the product page deployment, we'll see that in that product page deployment, there are 3 containers: the Istio proxy, the OPA Istio, and the product page itself. And then to show you the configuration map, the config maps that are required for the OPA configuration, you'll see that in the same default namespace, there's OPA Istio config, which is going to just be configuration for some of the components. And then there's going to be the OPA policy, which is going to encode the user permissions. Here you can see Alice as guest and Bob as admin. And the last thing I want to show here is that with this deployment, if we look at the Istio components, we will see that there is the external auths EnvoyFilter. And this EnvoyFilter is going to use the localhost. Since it is a sidecar, it can just communicate with 9191, and that will give access to the OPA agent. So to prove that this all works, I'll go back to my terminal, and I will clear that. I will make sure I'm in the right cluster. I will get kubectl get nodes out wide to get the IP address of a node. So we have this request. If I were to do a curl -I so that I can get the status, HTTP, oops, there's a space there. Let's get rid of that space. Oh, that one's saying 404 not found. Oh, I gotta put the port at the end. Here we go. We can see that I am getting a forbidden request. And then if I add user credentials for Alice, you'll see that, let's double check that Alice has access in this environment. 1 second. I am going to look at my Chrome browser for a second. User Alice. Let me switch over to my console. There we go. I want both I and oh, I guess big I doesn't work. But we pass in the username, we can see that there. And then if we were to pass in the additional API v1 products URL, we'll see that Alice is forbidden. So similarly, if we were to do the same thing with Bob, we would see that he does have access. We can see that he gets a 2000 status. And so what this is going to allow you is just a way to configure with a little bit more complexity, I would say, whether or not using authorization through another system, as opposed to just using native, maybe like a third-party system, something that you can control entirely internally. The last component, and I'll kind of speed through this because I've already gone way over time, is Istio Upgrades and Istio Futures. Istio Upgrades, you have the option to use Canary Upgrades. At first, they were something that I toyed around with but didn't recommend for production. But at this point in time, I would say that Canary is going to be a reasonable approach to maintaining your Istio service mesh, primarily because it's just using standard Envoy configuration components, and you have the ultimate control over when the sidecars are going to be deployed. As you can see, this last step here, sidecars will not be updated until the deployments they're running in are redeployed. So things will be in your control from start to finish. The next section was in-place upgrades. If for some reason you can't run Canary Upgrades, you always have the ability to run in-place upgrades. so you don't need to do additional configuration outside of cluster or remove and then bring back up. The cluster has to be installed with Istio-ctl. The upgrade must not be greater than one version. It's a basic Istio-ctl command. It's Istio-ctl upgrade. And then you also have the added benefit of being able to do downgrades. So downgrades are going to have the one requirement that you have to be running the downgraded, the downgrade destination from the target for the target situation. So if you're going from 1.8.4.1.8.3, you would want Istio-ctl to, or well, let's say 1.8.3 to 1.7.3, you would want to be running the downgrade command with Istio 1.7, Istio-ctl 1.7. And then the last component that I want to talk about is what's happening with Istio in the future. The first one, and this is something that's gathering a fair bit of traction these days, is that Istio is aware of and going to be making changes in relation to the Gateway API, which is a Kubernetes SIG to modify the way that ingress is being handled. Ingress right now is not a very standardized field, and the Gateway API intends to correct that and apply different role-based domains. You'll see that Istio 1.9, if you have an Istio 1.9 cluster running, you can enable the service APIs, and there is even an example in the Istio documentation to see what that would look like. And the important thing here is that they are moving forward. The Istio team is moving forward with the idea that they will be supportable through Istio, and the transition between the two won't be a disruptive transition. So the idea here is that Istio will work explicitly and implicitly. So you can have the calls out to the way that you're doing it currently explicitly, or if you want to migrate over implicitly, some of the ingress functionality will just fall out of the configuration. And here's something that I quoted from that presentation that I watched at SUSECON, is that existing APIs, virtual service gateway destination will stick around for a long time, even after gateway APIs are promoted to stable. So Istio, as you're probably well familiar with already, moves rather fast. And this is a good indication that even if it does continue to move fast and switches over to using gateway APIs as a standard, you'll still be able to use the resources that you created until you're safely and comfortably migrated over to the new system. In addition to that, Istio and WASM have been receiving a lot of momentum these days. WASM functionality was introduced in 1.5. As of October 2020, WASM was merged directly into upstream Envoy, which is good news for downstream Istio. Istio is going to continue to release components that make WASM a first-class component. That being said, with Istio 1.10, there is the expectation, well, Istio 1.10 or later, the expectation that WASM extensions will be removed from the EnvoyFilter resource and made their own customizable resource, similar to the way that, in a manner that's going to enable functionality like the rate limit operator that I talked about previously did. There are going to be artifacts to standard. The artifacts are going to standardize on the WASM OCI image specification so that you can load them in the standard registries that are already using other OCI image spec artifacts, such as Helm charts. And then the storage of binaries to be used optimized potentially using the Ephemeral CSI. So that's more or less on the implementation, and that's something if you are running a large-scale Istio service mesh is going to become more important. But for smaller users of Istio, it's going to be more or less an implementation detail. And the last thing I want to mention before I let you all go is that Istio has basically gotten to the point where you can run everything, all of the control plane components outside of cluster, and manage a single or multiple clusters with that remote control plane. And the benefit here is that, as you can see, the architecture, that's going to be more or less just Istio-D and a gateway that communicates over a couple of endpoints to the mesh or meshes that you want to control. And the benefit here is that you'll probably start seeing a lot of Istio as a service providers pop up on the internet. I know Solar.io has Istio as a service, and they'll control your mesh because they have mesh. It was Service Mesh Hub originally, and now it's called Glue Mesh, I think. I'll have to fact check myself later. But I expect to see that to be more common, and hopefully that will increase the amount of adoption Istio has had, because it'll make the process of maintaining it and updating it just a service that you pay for, and you can get to the actual implementation of how your service mesh is going to be employed, and looking at the virtual services, the destination rules, just getting the value out of a service mesh without all of the maintenance overhead. So that being said, that's just about all I have for today. I'm well over already. I think I'm 17 minutes over. I hope something in that was useful to you. If I said anything that was in error, please let me know. I can be found on the Rancher Slack channel. You can email me directly. I'm sure my email is available through the SUSECON portal. But beyond that, I hope you enjoy the rest of your sessions, and I hope you all have a wonderful time deploying service mesh in some level. Take care.